Hey guys, welcome back to the coding interview pattern series. So this is the 7th video in this series, and this one we are going to cover the greedy techniques. So as the name suggests, it's like becoming the greedy while we are solving the problem or finding the solution. So what we do is our decision will be based on the greedy nature. And in other words, it also called that locally optimal solution. So you decide the best at that moment. You take the best decision at that step at that moment. Now the thing is, how it works is that hey, if you start from here this point, and suppose you keep moving this one, or maybe you have multiple direction, you think that at this moment what is the best I can do it, without thinking about all other stuffs. You just think okay, at this moment this is the best decision I can take it, and you take the decision. Then you can move it on maybe this direction or this direction. Suppose you came here, then again at this moment you think that what is the best I can do it, or what is the best thing or action at this moment. Now as I said, you take the best decision at that moment, which is locally optimal. So at this moment, at this stage, it is optimal. But it doesn't mean that once you reach to the end of the solution, it will be optimal. So it doesn't give guarantee that this will be globally optimal. Globally optimal, there is no guarantee. It might be. Now, then still why we use this one? See, there are some problems which we don't know full picture. We need to have the best decision at some steps. So we need to apply these techniques only to solve that problem. And in some problem, even it's not guaranteed, we get the best globally optimal solution. Now how it works is, see, the thing is, we can't come back. Once we have taken the decision, once we have moved from one step to second step, even if you feel that hey, from here I came this step, and at that step we felt hey, this decision I took was not best decision. There was 2-3 decisions were there, 1, 2 and 3, and I chose that one, and you came this point. Now you feel that hey, this was not the best, I could have chosen this one, but you can't do it. You can't go back and change the decision. You need to take the best decision at this moment, and at this moment you was feeling or you found that this was the best decision. You take the decision and move it. Now let's see. Let's take some more example. Let's say you might have played the coin collecting some games. So suppose you are here, and there are 2 directions going from here. Then again you reach here, and from here also 2 directions are there. Then you reach here, then again some 2 directions are there. So here 2 directions there, and suppose this is some destination. Now on each direction there are some points. So if you go from here, you will collect 10 points or 10 coins, you will collect 5 coins, you will collect 3 coins, you will collect 15, you will collect 25, you will collect 10, maybe you will collect the 30, you will collect the 5, you will collect 12, you will collect maybe 50, 5, let me give 5, 50 may not be okay. And at this point I'm just keeping random number, 6, you may collect here 18, here 3, here 1. Now let's find what is the sum of this coin. So if you go from this direction, 10 plus 30, so it is like 43. If you go from this one, 10, 15, 18. If you go from here, it is 10 plus 25 and 12, 37. Just correct me that if I am doing something mistake in calculation. This is 15, 20 and 30. This is 5, 25, 30, 36. This is 18, 5, 30, 30 and 18, 48. And this one again 10, 15, 15, 18 and this 11. So if it's used from this one, this is the best one. Okay, so, no, sorry, not this one. This 48 is the best path to choose it. Globally, this is the best. You can earn the lots of coin. Now you know this one all the path. Then when you start, you are here, and you start from here. Obviously, you will choose this path because you know this one. You will choose this path and this path because you know that I will earn the highest coin in this path. But you don't know this picture. You are here. You just know this much. So you will choose the maximum or the greedy path. You will think here that hey, oh, if I go in this direction, this will give me 10. If I go in this one, it will give me 5. So I will go in the 10. So we will choose this path 10. So as per greedy technique, what path will be chosen is this one. We will choose this 10 because this is the best one. After coming here, we will again compare what is the best. So we will say 15 is best. So we will choose this one. After coming here, what is the best? You will choose, okay, this is the best. So we end up coming here. Now this is not globally optimal because this is not highest coin you can collect it. But as per greedy one, you will choose the best decision which is locally best. So this is your become local. This is your local, you can consider it. So within this local, you will choose the best decision. Then again within this one, you will say okay. So for this, suppose once you come here, this part is local, not full. Only this part is local. And then again only this part or this part become local. So this is how the greedy technique works end to end. Now let's take one example that how we can solve some problems, coding problem using this technique. So let's say there is one jump game from where if you jump from one step to second step, you can take that many steps. So let me do it. So here you have the 4, here you have the 2, here you have 0, here you have 1, here you have 1, here you have 2, and this is the 5. So what you need to do is you need to move in this direction. Okay. So suppose at the number mean that you can take that many steps from that position. So if I say from here maximum you can take 4 steps. So it's not necessary you can take 3, you can take 2, 1, but maximum you can take the 4 steps. Now what is the problem is that you need to find it that if a person start from here, he will be able to reach this destination or not. If he will reach there, that means he will win the game. So will he win the game or not? Based on this number, we need to find it. Now if we think from this perspective, if we just see this one, we will say okay, 4 steps I can go from here only, or I can go here, or I can go here, or I can go here. So all the 1, 2, 3, 4, I can go up to here. Now you will take the greedy decision, you will go here for 5. Up to that you can take only 1 step, so you will go here. From here you can take up to 1, so you will reach here, you will win the game. So you won the game. Okay. So from this number it said that you will win the game. Now let's change some number. Let's say I am changing this 1 with the number 0. Now if I take the decision, hey, 4 is there, I need to retake 4 steps. So I come here, but from here I cannot go anywhere because this is 0 steps. That means I cannot go here 4 steps. I need to take less than 4 steps. Now I have 2 options. Suppose I can take, instead of this one, I take here, go here, then it will go here again 1 step, so it will go here, and then again I cannot win the game because it's become 0. If I take here, then obviously I cannot go anywhere. If I go here, then come here, again it will take 2 steps, again it will take 1 step, I cannot win the game. So that means in this one, he will never win the game for any competition. Now, let's change little bit more. In this one we said, in last one, we said he will win the game in each stage. In this one, he will never win the game. Now, let's change little bit. Okay, let's keep it 0 only. Let's change it 2. If we think now, he will take the first step, he will not win. He will take 3 steps, he can come here. From 2 steps, he can come here, and then he can take maximum 2, but he will take 1 step and he will win the game. So we need to find it that he will be able to win the game or not using grid technique. Now in this example, if we take the grid technique from here, then he will say maximum I can take 4 steps, he may not win it. So what we do, we need to move little bit on the back side. So I am not going to do the coding for this problem, we will do coding for next problem, but what we need to do, let's explain the problem or solution. So what we will do is, or if we want to do coding, how we can do it, we will say okay, my target is this one, this is my target or this is my destination. Now I will go in the back and see, let me see who can reach to me, and I will make that as target. So if I go back from here, I will go in this direction. I will say okay, he can reach to me. Okay, I will say okay, you are new target. I don't care if someone able to reach like 1 jump. I don't need 1 jump. I need the best solution that hey, you can reach me. Let them to reach to you. They don't want to reach to me because you will be able to reach to me. So in this case, our target was this one. Now become this target. Now what it will do? It will go back and say okay, you can reach me. You will say I cannot reach you. Okay. It will ask you can reach me. Yes, you can reach me, then you can say, okay, you can become new target. So this become new target. Now it will check that one, that hey, can you reach me? Okay, he is not able to reach one, this one. Okay, so that means this become new target. Now it will come here, you can reach me, yes, you can reach me. That means once we reach to index 0, that means he can win the game. Now what he is doing here? He is saying he is taking the best decision. Now see, if you consider from this point, he has chosen this personal target index, but he was also able to reach here, but he didn't check. He took the greedy decision that hey, you are the nearest one, you can reach me, it's fine for me, I don't want to go ahead and check more part. So he limited the decision based on the best optimal choice. So this was the best optimal choice. He took the decision without checking the further data, and like that he solved the problem that hey, he can win the game or not. You can try to do coding in the Eclipse. It's like again, as I said, you just need to have the while loop. You need to set the target index this one, and then go in the loop in the reverse. Reverse means from this index to this side, and keep checking this. Who can reach to this position? If someone can reach that position, assign that as the target index. Again check whoever can reach that one, assign target index. At the end, once you come out of this loop, if the target index is 0, that means he can win the game or he cannot win the game. So this you can implement it. We'll take one more problem. For that we will do explanation. We'll try to solve that one in this whiteboard, and then we'll do the coding in Eclipse 2. So let's take that one more problem. Okay, so we will take two city scheduling problem. 2 city interview scheduling problem. So what if the problem statement is, there is one company who is trying to schedule the interview for the few candidates at the 2 different locations. So let's say location L1 is the Bangalore and second location is the Pune. Now company has decided the two spots to schedule the interview. Now candidates are coming from different region. So company trying to find that which candidate if I call here and which candidate if I call here, so that candidate cost will be minimum. Now the constraint is at both place we need to have the 50% candidate. Okay, some candidate may need to bear the more cost compared to other, but still they have to, this balance we need to make it. We can't do that, hey, if we call all the candidates at Bangalore, the cost will be minimum. No, that constraint we need to follow this 50-50. So that we need to keep in mind. So with this one, how we can solve the problem? So first let's understand the problem. We need to keep the minimum cost. We are not saying that we need to keep the minimum cost for each candidate. But at least we can try to solve as much as possible. So what is the data is available for us is, let's say let's take example with two candidates. So let's say candidate A is there. If we come to Bangalore, his cost will be, let's say, 100. And if you go to Pune, this is second location, his cost will be, let's say, 40. There is one more candidate B. If he goes to Bangalore, his cost will be, let's say, 50. And if he's come to Pune, his cost will be, let's say, 90. Correct. Now if we think by default from here, we obviously choose these two. We will say, okay, candidate 1 send to the Pune, candidate 2 send to the Bangalore, and total cost will be 90. If we do reverse, will become 190, which is the more. If we do this one. So this is the minimum cost with, if we do this much arrangement. Hey, second candidate send to the, first candidate send to the Pune, second candidate send to the Bangalore. But this is, we have two candidates, we have hundreds of candidates. How we can take the decision? That also using these algorithms, using the coding technique. So let's decode this part, the decision, how we took it or how we can take this decision. Okay, so let me remove this also. Okay, let me rewrite this data. So let's say I have the location. I have location 1, L1 and L2, which was the BLR, Bangalore and Pune. Okay, Bangalore and Pune. Now I am saying for the Bangalore location, we have the candidate A1 and we have A and we have candidate B. For candidate A, what is the cost for the location BLR? 100. So we are saying 100. For the candidate B, what is the cost for the Bangalore? Location 1, which is the 50. Which is the 50. For candidate A, location cost for location 2 is 40. Candidate B, second location cost is 90. So we just rearrange data. Same data is still there. It was the if we maybe you can say the two-dimensional array. I just separated the two array. Now what we will do is, we'll take difference of these two. We will understand how we will solve the problem. So if I take a difference, see difference means I will take always A minus B. 100 minus 40, it will be 60. And 50 minus 90, it will be all minus 40. This is done. Now, so this is the index 0, this is index 1. Now we'll sort this array in ascending order. So if we sort the array, our new array will become -40 and 60. Here this was the first index, this was the 0th index. Correct. Now what it says that for first half, so if this is the length 2, so if I do n by 2, which is the 1, so for the first n by half candidate, take the first city, and for rest of that one take the second city. Again, for the first half candidate, take the first city, for second half city take the second city. So for first half we have the one index. At the one index we have the B. For B we took first city. For second half, which is only 61 number, 0th index, we took the second city. So this is, we know how we got it. But now why we are saying that if we sort it, it will work like that, that if we do n by 2, for first n by 2 we will take first city, second rest of the part we will take the second city. Why it works? Why it works is because we are taking the difference of the cost of the two cities. Now if difference is large, that means the cost of the second city will be very less. Or in other words, that means the first value or the cost of the first city was very high. Let me give you one more example. So for this one, let's say candidate A, his cost for reaching one location is 11 and other is 10. Candidate B, reaching the cost is 12 and for the second location it is 9. So what we'll do it now? If you take the difference, both of them, for first 0th index, difference is what? 11 minus 10 minus 1. For 1th index, what is the difference? 12 minus 90, which is minus 78. Now if you sort it, it will become minus 78 and the minus 1. So that means at the minus 78, we will take the first location, and for minus 1, we will take the second location. So for this one, we will take the first location, in the second location, 50-50 we are doing it. Minus 78 was the for first index or candidate B, or I can say candidate A, candidate B. So for this candidate B, we will take the first location, which means this 12. For candidate A, minus 1 will take the second, which is the 10, and this will cost 22. If we have taken this one, it would have cost 101, which is the higher. So this is how you can solve the problem, by just taking the difference and then sorting the array and then taking the first half at the first location, second half for the second location. So this is that's it on this whiteboard side. Let's move on the Eclipse. Let's see how we can code it and derive the solution in the programming language. So let's move on the Eclipse. Okay, we are back to Eclipse. So let's create the class for this new problem. So this is two-city interview problem. Okay, so just defining main method we'll use later. Okay, so now what we saw in the video is that we need to define one method which can return the total cost for that all the interview schedules. So that means our method will return the integer, which is the total cost, and we can say del total cost for interview schedule. Okay,
Now what we need to return it, we need to return the total cost, which is, let's say, initialize with 0, and we can return it to avoid the errors compile time. Okay, what we input, we get it, we get the input as the cost of the candidates for the two cities. So it will be the two-dimensional array which will say the costs of the each candidate for the two different cities. Now what we saw in the video, what we say is we will sort the data based on the cost different for the two locations. So that means in the first step we will sort the cost data based on location cost different. Okay, that means we will sort this cost, this whatever array we received as the input, we will sort it array dot sort now what we'll do, we are saying how we want to sort it. We want to sort it based on the location difference. So we are saying if you find the two array, or say two object here, and in our case it's array because we have the two-dimensional array, so the object will be array. So if you find the two array, how you sort it? We are saying sort it based on what I say, which means take the difference of that candidate for the first location and the second location, which is index 1. Same thing for the candidate B, first location minus second location. So this will give us data sorted based on the cost difference between the two locations. Now that means we have the data what we wanted it. So data is ready. We don't need to do much. Once data is ready, what we need to do it, we need to take first half as for first city and second half for second city. So what we are saying is that the first half candidate, after this sorting the data, first half the candidate sent to the first city, second half candidate sent to the second city or second location. So we'll do for loop for the first half. Let's say I equal to 0. We'll start with 0 and we'll do I less than, how much we'll do? We'll do length divide by 2 because we want to do half I plus plus. Okay, so we are calculating the cost for first half. So what we will say, our total cost, we'll just keep adding this one, will be cost of that candidate for the first city, which is the index 0. So we are considering I, which will give the candidate, and we are saying first index will give the cost of the first city. So if we complete the, once we complete the loop, we will have the cost of the first half. Now we can have the second loop to calculate the cost of the second half, but we can also include in the same loop. So what we'll do is, we are saying we need to have the cost of the second half means what? Cost of, so that means what is the index? The index will be cost of length minus 1, which is the last index. But we need to keep changing in, that means we need to minus I also. So in the first iteration, it will give the last index because I is 0. In the second iteration, it will give the second last. And we are saying we want to get the cost of the second city, that means index 1. So we'll change the index 1. And that's it. It's just 4 to 5 lines of the code. And which tell us that it's not always to write the hundreds of lines of the code. It's always to apply the proper technique, apply the proper algorithms. Now let's solve it. Let's try to see how it looks. So what we need here? We need input as the cost. So let's define our costs. So so it is again two-dimensional array. We want to define it. So let's say for the first candidate, it will cost around 140. For the second candidate, it will cost around 50 and 90. I think I'm taking the same data what we saw in the video. Now let's get the total cost. Integer total cost is equal to, and we are passing the cost. Let's print it, and that is the total cost. Let's run the program and see how it looks. Cool. So it took the 90 because for the first candidate it took the second location. For second candidate it has assigned the first. You can try it with other some input and see how it looks. For now, let's talk on the time complexity here only. So for this one, if you think about our solution, we don't do much. We just do the one for loop and we do the sorting part. So in the for loop, it is just n time. It's n by 2, but again we going to consider n. But we are doing the sorting algorithms. We are not doing we are using the methods, but it will take the inside it will use some sorting algorithms. And for that, the time complexity will be big of n log n. So for the time complexity of this solution will become the big of n log n. On the space side, we are not using any space. We are just using total cost, one constant space. But again, the sorting part will take the space and which will be big of n time complexity. So that's it on this video. You can try to solve other problems. You will find in the Google. I think there are some popular problems like gas station filling and something related to bots to save the children's. So you can search this one. You will find the problem and try to implement using these techniques and see how it looks. So we'll meet in the next video. Thank you for watching.